We're now going to talk about another form of vapor power cycle that makes or takes advantage of the fact that there is waste heat that is being generated in a vapor power cycle. And the idea behind this next area, cogeneration, is that you can take some of that waste heat, and if your power plant is located next to a location that needs heat, either process heat or space heating, something like that, you can gain efficiency advantages. So cogeneration, we can see it's an application whereby we both need electricity, so power production, as well as thermal energy for heating. And quite often these systems will be, as I mentioned, places like college campuses or hospitals. There are, however, certain places where this is used for municipal heating, and probably the most famous or well-known and probably the most successful globally would be the city of Copenhagen in Denmark. So what I have here are a few pictures that we're going to take a look at a system that is in Copenhagen. And what we'll do is we'll begin, this is a power plant called the H.C. Ørsted Værket power plant, which is in the city of Copenhagen. It produces 185 megawatts of electricity and 850 megawatts of thermal energy that is used for space heating. It is a gas-powered power plant. It was converted from coal back in about the 90s. And then within the city of Copenhagen, there's a distribution network of about 1,500 kilometers of insulated pipe that goes and spans throughout the city. And it's a fairly extensive network, and if you go into the downtown core of Copenhagen, you'll see the pipes. They get smaller and smaller, and there you can see a picture of one. It is an insulated pipe, and so there's a certain amount of insulation around the outside of the steel pipe wall, which then retains the thermal energy, either steam or liquid. And then eventually that heat goes into the residences throughout Copenhagen. Currently 98% of the city uses this type of heating. And that represents about 30,000 residences for the 500,000 inhabitants within the city. So hats off to Copenhagen. It's one of the best in the world in this area. So what we're going to do now, let's take a look at cogeneration, and I'll draw out a schematic of what a cogen power plant may look like. So what we have here is a process schematic of a cogen power plant, and we can see it's similar to what we've looked at thus far, with the exception of this part in here. And what is happening here, we're taking some of the heat and we're then using that for a heating load. So that would be the case for maybe you need process heat at a high temperature, high pressure steam. In the case of the pictures that we looked at in Copenhagen, however, it would be more likely that they would be taking the thermal energy that would be rejected from the power plant and using a lot of that then to send throughout the city and provide heating for the residences within the heating. So, but they may also be taking some of this up here in the event that they have steam heating for some of the areas, which I believe they do in the inner part of the city of Copenhagen. So when we have this, what we can say, before when we looked at thermal power plants, we always talked about the thermal efficiency. Now what we do is we introduce a new coefficient, and it is called the effectiveness. So with the effectiveness, we have the net workout plus whatever load heating is being provided. That could either be process heating or it could be heating for residences, for space heating. And you divide that by the heat in, and that is how you determine the effectiveness. Now, a couple of comments that we can make here. Thermal efficiency for the power plants that we looked at, remember we looked at reheat, we looked at regen, all different types of combinations there, but typically the thermal efficiencies that we're seeing were roughly in the ballpark 30 to 40%. When you add cogen, your effectiveness, so the amount of energy that you're getting out of the system, is typically higher. And so right there we can see that if we're going from 30 to 40% efficiency up to 55 to 70, it makes a lot of sense to be able to take advantage of cogen for any type of electricity production and heating application. The trick, however, is that you need to have your residences fairly compact, which is what they have within Copenhagen, and you also have to be able to run the process heat throughout the city. Or what you do is you locate your power plant next to another plant that might need thermal energy, and that way you can get the benefit as well. So that is the cogeneration cycle. The next thing that we're going to take a look at is going to be combined power cycles.